All right. Well, good morning, good afternoon, everyone, and welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Borowski, and I'll be your host for today. We're quickly coming to the end of March and getting towards our April lessons, but we still have quite a bit of action coming your way between now and March 31st. So do head to our website, exploringbytheseat.com. You'll find all the new events coming up. And then we've announced a lot of our April events. So the first 2 weeks, at least, of April are up there. And in the next newsletter, we will be announcing even more. So we look forward to seeing your classes joining us live or catching some of those recordings. So today's event is going to be a great one for a Thursday. Over the years, we've been collaborating with the Department of Fisheries and Oceans on a series of great events where we get to meet some of their scientists, some of their researchers, some of their science communicators who are out in the field doing really exciting work on our freshwater, in our saltwater, looking at plants, looking at animals, water quality, water levels, and everything in between. So today we're going to spend a little time with Ashleigh Westfall. She is a biologist working with Fisheries and Oceans Canada, monitoring beluga whales and the marine soundscape in the Western Arctic using underwater recorders. So today we're going to learn a little bit about beluga communication. We're going to learn about underwater sound. And then most importantly, we're going to learn how scientists are monitoring beluga whales in a changing Arctic, because our polar regions on both parts of the planet are changing 2, 3, even 4 times faster than other places. So let's grab Ashleigh right now and bring her into our hangout today. Hey, Ashleigh, how are you?
Hello, I'm good. How are you guys?
Good, good. It's great to have you with us today, Ashleigh.
Great to be here. Thanks for having me.
Where in Canada are you joining us from today?
So, I'm actually joining you guys from southern Manitoba, just outside of Le Manitoba.
All right, very cool. Well, we've got a great group of classrooms. We've got some classrooms in Canada and the US hanging out with us today. We're going to turn them loose with questions towards the end of the event. But before that, we're going to let you take over for a little bit and take us into your world.
Fabulous. Okay, just give me one moment here to get myself set up, everyone.
The moment of truth. We've done our tech checks. Everything looks good. But I think most classrooms know technology can sometimes surprise you. But I like what I'm seeing backstage. That looks pretty
Hooray!
good. All right, here we go.
Okay, fabulous. So, thank you everyone for tuning in today. I'm very excited to share with you all a symphony in the Arctic. So, I know Joe has given me a bit of an introduction already, but we're going to be talking about beluga whales, underwater sound, the soundscape up in the Arctic. And specifically, we're going to be talking about how researchers use sound to monitor beluga whales and other things that might be going on in our Arctic soundscape. My name is Ashleigh. As mentioned, I'm a biologist with Fisheries and Oceans Canada. I've been a biologist for about 10 years now professionally. I've studied species ranging from birds to butterflies to beluga whales. And it's very exciting to get to share with you guys today a little peek behind the curtain of what we do in our northern ecosystems. So, we're going to be talking about beluga whales and beluga whale communication. That's the star of the show. But to set the stage a little bit, I want to first talk about sound. So, what is sound? Sound is a vibration. So it's an acoustic wave of vibrating molecules that moves through an environment, whether that be air or through water, and it's perceived by our ears, that vibration, and our brain helps translate that into the sound that we hear. In a nutshell, the way sound moves through the environment is going to change a little bit depending on whether or not it's moving through air molecules versus water, what's maybe in the air or the water. But essentially, it's a wave of energy or vibrations that our ears and our brains perceive. The stronger those vibrations are, the louder the sound, all of those great things. But oftentimes, when we as scientists are looking to see what's going on in the soundscape and look at sound more closely, it's usually not as clear as a diagram like this one here, where we're seeing a beluga sending out sound in the form of these waves towards these fish, and then that is being reflected back to the beluga, and they can hear that reflection, which is also echolocation. Oftentimes, we have to use other types of tools to let us know what exactly is happening with the soundscape and with the sounds that we're hearing. So with that in mind, I'm going to be showing you guys a little bit of a tool, one of the tools that we use to look at sound in a sense. So this is a spectrogram. This is a type of graph that lets us visualize what the sounds are that we're hearing. Basically, what we're looking at is a sound. So this is 8 seconds of a sound file, and this is the frequency of the sound. So you can think of frequency as the speed at which it's vibrating. So something at the really high end of this frequency scale, it's going to be vibrating very quickly, and it's perceived to us as something that's higher pitch, um, versus something, for instance, at the low end of the scale, that's going to be something that's lower in frequency, and we're going to perceive it as something that's lower in pitch. Something else that we can see looking at these spectrograms are the amplitude, or what we perceive as how loud a sound is. So areas on this particular spectrogram that are this bright green color, or maybe even veering towards like yellow or white, that's going to indicate a higher amplitude or louder sound. And areas that are darker, so looking at these areas that are maybe black or blue, lighter blue, those are going to be a little bit quieter. The amplitude is a little bit lower. So we're getting a lot of information just by looking at one of these spectrograms. It tells us a lot about the different sounds that we're listening to, the character of the sound we're listening to. And I'm actually going to play this sound for you guys in a little bit, so you'll actually see what this translates to. But in a nutshell, you guys are now all experts in how to read a spectrogram and how to visualize sound. So what about with hearing? So we as humans typically are hearing kind of in this range, this lower end of the frequency scale. Typically 20 kilohertz and lower is where humans will normally hear. For beluga, it's all the way up. Think 120 kilohertz. So beluga have this huge range of hearing that we as humans don't. And that's part of the reason that sound is such an important tool for beluga. They use a lot in their environment. They communicate a lot. They need to hear. And it makes sense for them to have a much broader range that they can hear across. And we're going to get into some of the nitty gritty of why that is in a bit. But now that you guys are all experts in how we interpret sound, how we look at sound, let's get to the star of the show, beluga. So closing your eyes for a moment and thinking about when I say beluga whales, picture a beluga whale, you're probably thinking something like this image here. We're thinking about a kind of mid-sized white whale species. They're found throughout the Arctic. What's kind of cool is beluga are actually born dark gray. So this little guy here is a baby beluga. Babies spend a few years with their mom, a few years nursing, and as they grow and they mature, they gradually lighten to this white color. Beluga are very social animals. So getting back into that sound side of things, they love to communicate. They're very chatty. They make a whole wide range of different sounds from squeals to whistles to almost like seagull sounds or creaky doors or all sorts of different things, clicks. So they're very, very social species. You'll see them gathered in groups anywhere from a couple of individuals all the way up to dozens or even hundreds. And help you guys visualize that a little bit, I'm going to play a video for you in a moment. Couple things about this video before I play it. A lot of beluga populations, they're migratory, not all of them, but a lot of them. And what that means is they have an area where they'll spend the winter, and then they'll have another area that they'll move towards where they'll spend the summertime. And oftentimes that has to do partially with where ice cover is, and as ice cover comes off certain areas, they like to move to areas that are really productive and have a lot of fish, a lot of food, a lot of great things, maybe safety. And a lot of times too with some of these summer areas is it becomes a really great place for a lot of beluga to come together and gather and be social and communicate with one another as well. So this here is some camera footage shot from a drone over top of a summer area. All of these little grains of rice that you're seeing are beluga whales. So as you're watching this, I want you to have a look at all of the different little groups, how big they are, how the groups are interacting with one another. You can try and count how many beluga you're seeing in the video as well. And something that I also want you to do is listen. So when we talk about a soundscape, if you were to say close your eyes in your classroom, or maybe you're out in a park, you're maybe even at home, and listen to all the sounds that are around you, whether that be people chatting, or maybe you hear animals, maybe you hear wind, maybe you hear cars moving past. All of these sounds coming together make the soundscape around you. So the landscape of sound. What I'm going to play over top of this video is the soundscape underneath the water. So this is recorded underneath the water surface, and we're going to hear a little bit of beluga chatter. We're going to hear a little bit about what beluga hear as we're watching this video. So let's have a look. Hopefully that wasn't too choppy, but pretty loud, right? There's a lot going on. There's a lot of chatter happening. A lot of different whales are talking over one another and trying to hear one another and try and listen. So that kind of gives you a bit of an idea of just the huge range of sounds that belugas make and how much they do love to communicate with one another. Putting on our scientist hats again, let's take a closer look at some of those calls that we're hearing. So let's visualize. This here is going to be a sound file of the spectrogram that we were just looking at together. So same thing we were just chatting about. We have the frequency along the side. Sounds near the top are going to be higher frequency. Sounds near the bottom are going to be lower frequency. And as I hit play, we're slowly going to move through the spectrogram as we move through the time in the recording. What we're going to listen to here are called contact calls. These are calls that beluga use to help keep in touch with one another. Moms and calves use them quite a bit to keep tabs on one another. They tend to be really broad spectrums or broad frequency spectrum. So they almost look like these broad pillars of sound with kind of a little bit more amplitude and intensity towards this range here. And what that's kind of great for is to help cut across a lot of other noise that's going on in the environment. So wind, waves, ice, but as well as chatter. So you guys kind of heard in that last clip how much beluga can talk over one another. These calls can be really great for really kind of crossing a spectrum and hopefully getting in touch with everyone you want to get in touch with. So let's have a quick listen. So hopefully some of those you were picking up on the last recording. Let's take a look at a very different type of sound that beluga will make. So whistles. You probably heard a lot of whistles in that last video with that drone footage. Whistles, in contrast to the contact calls, they have a very kind of narrow bandwidth. So they look like these very tight little intense squiggles on our spectrogram here. They can kind of be at a few different areas of the spectrum, but keep in mind a lot of these are pretty low frequency that I'm playing for you here. And we think that they kind of communicate a whole variety of different things and probably help differentiate a little bit between different members of your group and different things that are going on. But as we're listening to this one, really try and visualize the sound that you're hearing. So you can really kind of almost you can see as you follow along the sound how it kind of squiggles and how what we're looking at here really matches what we're listening to. So all kinds of weird whistles going on, right? The last sound that I wanted to play for you guys is actually echolocation clicks. So I kind of alluded to this a little bit earlier, but in addition to communication, beluga actually use sound for echolocation as well. So the same way as maybe you've heard of bats using echolocation to see in the dark to find prey, beluga use it in a very similar way. They use echolocation to navigate in water, to find fish, to know where they are. And how they do this is by sending out these really rapid series of clicks called a click train. These tend to be higher in frequency. They also are very, very quick. And what beluga are doing is they're sending out those clicks and they're listening for the echo bouncing back towards them, same way we kind of saw in that diagram at the very start of the presentation. And depending on how they hear it, what's kind of coming back to them, it's going to help them figure out the size, the shape, the distance, and the direction of whatever object they're interested in, or just what's going on in their environment. So what we've done for this particular clip here is we've actually slowed it down. This is going to be at about a quarter of the speed that the beluga would actually be sending out the clicks, but we're doing that so that we as humans can actually hear it. So let's take a quick listen. So it almost sounds like clicking marbles together or something like that. But imagine that being 4 times the speed. And that's what beluga are actually sending out, and that's what they're listening for when it's echoing back towards them. So you can kind of get a bit of an idea that there's a whole lot going on. Beluga are using a lot of different sounds to communicate a lot of different things. So there's a lot that we as scientists can listen into when we're looking to learn a little bit more about what beluga are doing, how they're interacting with one another, and what's going on in the ocean around them. So now that you guys are experts in beluga sound, let's take a look at what our group has been looking at and how we're studying beluga. So the group I'm working with, we're working in an estuary in the northwestern part of Canada, Western Arctic. Specifically, we're looking at this area. This is the Mackenzie River estuary. And this is a really important summer area for a particular population of beluga whales. An estuary is where fresh water from rivers and other inland sources meets the salt water of the ocean environment. So as you can kind of see in the picture here, there's a lot of mixing going on. There's a lot of natural sediments and things like that coming in from the rivers and mixing with the salt water of the ocean. And while it looks really murky and maybe not super appealing to us to swim in, it's actually really great. It's a really productive environment. There's a lot going on under the surface. And that's one of the reasons why species like beluga really like these areas. There tends to be a lot of fish. Sometimes they really like the warmer waters. Sometimes they like kind of the fresher aspect of it. All different reasons why beluga like these areas. But you can kind of look here and see how murky that water is. If you have ever gone swimming in a lake or a river that's really murky, you've tried to open your eyes underneath the water, it's probably really hard to see, right? So you can't really kind of move around underwater and see where you're going. Similar for beluga here. So this kind of helps you really think about why it would be really important for you as a beluga to be able to hear really well and to hear a variety of sounds that are going on around you, because you're probably not seeing a whole heck of a lot in these really murky areas. So speaking of what we're hearing, we scientists are really curious about what's going on in this soundscape. Sound can tell us a lot about where beluga are, what areas of the estuary they use and might be really important to them, as well as it can kind of highlight certain things that we might be wanting to keep a closer eye on. Like, for instance, how are human sounds part of that soundscape and how much of that soundscape are human sounds, like, say, larger boats or things like that, making up of that soundscape. And the way that we do that, as maybe some of you have already guessed, is we actually put out underwater microphones. So these are called hydrophones. We put these in a variety of different key spots in the estuary. We attach them to floating buoys like this one, as well as we attach a variety of other instruments if we want to kind of look a little bit more closely about different characteristics of the water. And we take all that information at the end of the summer and we have a closer look. And we might see something like this. So these are more spectrograms. The color is a little different, but same thing. But we can see maybe there are some areas that are a little bit quieter, like this one on the upper left here, not as much happening. There might be some areas like this one on the lower left where there seem to be a lot of belugas chatting, a lot of activity. Uh, some on the lower right here where we're hearing a lot of natural noise. Like there's a lot of other noises going on in a normal soundscape environment, things like wind, waves, ice breakup, different things like that. There are other species out there other than beluga making noise too, other whales. There's also potentially human noises. So for instance, this is maybe a signature of a boat moving past, and you can kind of see based on how it has some areas of red here, how high the amplitude is in some of those frequencies. But all of these make up a very diverse soundscape across the estuary. So looking at the different types of sounds we're hearing and where we're hearing them, some of the information we can get from that might be where certain areas are important to beluga, as I was kind of saying. So here, for instance, we have a couple of areas that we think are probably areas beluga really like. Maybe we're hearing a lot of chatter versus other areas that maybe are a little bit quieter. Something else that we can look at a bit more closely is maybe more of those human-based noises. So for instance, boats moving through the water, you can kind of see here that boat moving through the water is taking up an awful lot of that spectrogram versus here's that same beluga call that we've been looking at. So if you're a beluga and you're trying to call over top of something like this, it might be really hard to make yourself heard and to hear others. And sometimes even too, we've seen beluga just don't tend to call as much when boats are moving through the area. So this is something that maybe we as scientists want to keep an eye on, want to better understand and better know where areas important for beluga, where are we tending to hear more about boat traffic, and how do those kind of relate to one another, as especially as we've kind of mentioned, the Arctic is changing. And so this is an incredibly special species. Sound is really important to them. Being able to hear one another is really important to them. So we really care a lot about understanding more about that soundscape, more about how beluga are using sound, how they're using areas of the estuary, and potentially how different human-based sounds might be interacting with that environment as well. And with that, I'm happy to answer questions. I hope you guys see how special beluga are, and they're a really amazing species. It's really cool to be able to hear them chat to one another underneath the water surface, and it's an incredibly special part of the Arctic marine environment.
All right. Awesome, Ashleigh. Thanks so much for that great presentation. It was really cool to get to hear the belugas and to get to see them because, we don't often get to see them with
Mhm.
them, a lot of them being so far north. Maybe if you go out Quebec way, you have a chance, maybe in the St. Lawrence or something like that, but definitely not hanging around most parts of Canada, that's for sure.
Absolutely.
Okay, well, before we take some questions, I'm going to put up a Kahoot quiz. While you were presenting, I pulled together a quick Kahoot quiz to see if our classrooms want to test their new knowledge. So I'm going to share my screen. It's going to come up here in just a second. All right, you should be seeing it right about now. You need to go to kahoot.it if you're going to join in today, kahoot.it. Then it's going to ask you for a PIN number, and I'm going to flash one of those up on the screen. There we go, 657-2379. Want to join in our Kahoot today? Kahoot.it. Okay. If you don't, your teacher could pop this up at the front of the classroom. You could shout out your answers to him or her. If you're joining from home, we always have home students joining in. Scan that QR code. Maybe you have a phone handy or a tablet. That'll bring you right in. If For some reason you can't join with technology, no big deal. You can still play along. You can see how you do. So you've got some students joining. We have some classrooms joining. That's great. We have our auto animal names generating. Maybe while we wait to see if we have a couple more groups join us, I'll ask you a quick question, Ashleigh. And this question is about the recordings. Do you have to be in the field to get those recordings, or can you listen in from far away?
No, that's a really great question. So yes and no. So we don't have to be physically in the field. One of the really great things about putting out these microphones is that we can kind of almost put them out and forget about them for a couple months until the batteries run out and the recordings kind of start to fill up the memory cards.
Yeah.
So we don't have to be physically there while we're collecting all this data. We can just grab it at the end of the season. I think there are different types of recorders where you can listen in a bit more kind of live type thing. And there's actually, I'm not sure if maybe folks here have heard of explore.org. I think they do live camera sessions in Churchill and other areas where you can actually see beluga in the summertime. And I think you can listen in as well, if I remember correctly, in a bit
Very
more of
cool.
that live kind of scenario. But for us, at least, we don't listen to ours live, but there are capabilities of you that would allow you to do that for sure.
All right. Well, it's just a fun website in general, explore.org.
Yeah.
Must be some cool wildlife webcams. You can check that out after today's event if you have some time. So let's get into this here. I have 4 questions, some true and false, some multiple choice. The quicker you put in the right answer, the more points you're going to get. The last question is a tricky one because you have to select 2 options, but we'll talk about it again when we get there. So first question, sound is sound a ray? Is it a vibration? Is it visible? Is it a feeling? What is sound? Is it a ray, a vibration? Is it visible, or is it a feeling? You've got about 6 seconds to get in your answer. Whew, good job, crew. Absolutely, it is a vibration. Let's take a look at our scoreboard. We got the sturdy ant holding down that top spot. I'm going to jump into some true or false action. Belugas use echolocation to help hunt fish. Is that true or false? Belugas use echolocation to help find their food. Got about 11 seconds. Oh, too fast. Good job. That's absolutely true. And you can see when we saw that estuary and we saw how murky, full of sediment at the mouth of that river, you can see why echolocation could be really important, because I bet you're not seeing those fish. You're finding them with that echolocation. The snowy goat, stealing top spot. We're going to go to another true or false. Human hear at the high range of the frequency scale. Is that true that humans hear at the high range of the frequency scale? Man, you guys are fast. And that is absolutely false. We're more at the lower range, whereas the belugas have a much lower and higher range of frequencies that they're picking up there. They're kind of stretching across that scale. All right. Snowy goat. Can they hold on one more question? This is the one where you have to pick 2. You have to pick 2 to get the answer right. What can we learn from soundscapes? Can we learn areas that are important to belugas? Can we learn how much they're eating? Can we learn how fast they are? Can we learn the spots where human noises are common? So what do you think are the 2 best answers? Areas that are important to belugas, how much they're eating, how fast belugas are, or spots where human noises are common? Oh, I see high answers at the first and last option, which is absolutely correct. We can learn where they're hanging out, where they like to be, help us pick which areas need to be protected. And then when we hear those noises, we know when we're getting that conflict, those human noises might be interfering with the belugas and what they're doing. So we've got to look at our podium. In third place, we've got the space unicorn. In second place, the snowy goat. Oh, that means we have a new leader. In that top spot, we've got Agent New. Wow, very good. Sneaking in right at the end to take that victory. Very, very cool. All right, let's stop that screen share. Thanks to our students for taking part. We'll kill the music and we're going to get to the Q&A action. So if you're joining via YouTube, don't be shy to use that chat sidebar. send us in some questions. But before we take some YouTube questions, we have Miss Paget's crew hanging out with us today. I am going to bring them into the call here so we can see them. Hey, Mrs. Paget's class, how you doing?
Hello.
There they are. If you want to unmute your mic, we would love some beluga questions or ocean questions.
Hi.
Beluga would be cool.
Hello.
Hi, my name is Parker. How big does a beluga whale get, and how far does the sound travel, depending on their size?
Ooh, those are great questions. And I wish I had a better answer for how big beluga gets. I don't know offhand. They're not the biggest whales around. They're actually kind of like a mid-sized whale. But I don't know, for instance, how many feet or how much they might weigh offhand. I feel like somewhere in the range of 10 to 12 feet long. I
Very
know I've
good.
stood on a
Yeah.
paddleboard before and they were like longer than the paddleboard, if any of you guys have seen a paddleboard.
Yeah. Google's telling us 11 to 15. So you're right on the mark.
Nice. And as for how far sound can travel, another really great question. And it's hard because it really depends. It depends on what's in the water. So different things can affect how easily sound can travel through water. Things like temperature, how salty the water is, how much sediment is in the water. All of those different things can kind of affect how far sound can travel. For our microphones, we typically think they probably pick up optimistically, maybe I think a few kilometers away typically. And others feel free to jump in the chat if I'm mistaken. But as for how far that they can call in general, all kind of depends on the what's going on in the water around them. And for other types of whales too, some whales are louder than others. It can travel a lot farther than say belugas can call. So kind of all depends. And even just how they were calling. So if you guys remember some of those spectrograms we were looking at and how some are really broad frequency, some are really narrow frequency, those different sounds are going to travel different distances too. So awesome question and unfortunate answer of it depends on a lot of stuff that's going on.
All right. Before I go to YouTube, do you want to sneak in another question or two? I can always come back to your class as well.
Can you come back?
100%. Okay. We'll see you again soon.
Okay.
All right. Let's get over to YouTube. First question I have is from some fourth graders. How often do you get in the field?
So for me, I've actually only just started with Fisheries and Oceans very recently. For our particular program, most of our field work is happening in kind of that early summer. So we're going to go up right as the ice is breaking up in the estuary, which usually is mid to late June, somewhere in there, depending on the year. And so we'll go out mid to late June. We'll start putting out all of those hydrophones to record over top of the summer. And usually we have teams that go and then we'll pick those up late August, early to mid-September, something like that, before the ice has started freezing back over. Because with a lot of these areas, so the area of the estuary in particular, it's only going to be free of ice for a pretty brief window in the summertime. So we as scientists have to make sure we're getting out there right as the ice is breaking up because beluga are waiting to get into that estuary usually. And we want to get out there right before the ice is starting to freeze up because we want to make sure we actually can get our instruments back before they're frozen.
All right.
So a couple times in the summer, usually for me.
Okay. Well, I've got some sixth graders in Saskatchewan who would like to know, do we know much about why they're white, why they kind of have that coloration?
Ooh, that's a great question. So when you think about the environment that beluga have evolved in, they're a very ice-adapted species of whales. So if you compare beluga to, say, for instance, other species like a killer whale, you can think of they have that dorsal fin on the back there. Beluga don't have one. And part of what we think the reasoning behind that is because they're very specially adapted to ice. If you're ducking in and around ice flows, you don't want to have a fin that's gonna be scraping on the ice there. But another nice thing about you being white is you're probably blending in a lot better to that environment of kind of being around ice floes, navigating around ice. Even when you're looking as a fish, you're looking up from underneath. If a beluga is against an ice sheet, probably not nearly as visible to you as a fish versus if you have kind of like that dark color against that ice. So probably a whole variety of reasons why they're white, but probably a safe bet that it has a lot to do with the Arctic environment that they've evolved into and kind of the special adaptations that come along with that.
Okay, well, that comes with a follow-up question about predators. So they're obviously, if they
Ooh.
have that camouflage ability with the ice, who's after them?
So belugas do have some predators. Things like, well, things like potentially polar bears can potentially take beluga. I don't know how common that is necessarily, but it does happen. Other species of whales, so killer whales potentially will um, predate on a beluga whale. Um, Other than that, I mean, there are other um, humans potentially. We have Arctic communities. It's a really important part of life in the north as well. But belugas, yeah, they have a handful of predators like those species, but you're pretty big, so at least they're probably relatively safe, especially in numbers. But
Yeah. All right, I've got a question from a group in Toronto that want to know, is it true that they shed their skin?
ooh, yes, it is, which I feel like is always kind of a weird thing to think about. So belugas do kind of slough off their skin. Sounds a little bit gross, but yes, they do. So I kind of had an image a little bit earlier that showed it a little bit, but sometimes what you can see with photos of beluga, you'll almost see they have a bit of a yellowish or a bit of a funny pattern looking to their skin, or it might look a little bit wrinkled. That's kind of their skin getting ready to molt off. And sometimes it can kind of molt off all at once in what's called a catastrophic molt, or sometimes it can just kind of gradually slough off over time. And we think potentially that's one of the reasons why they might like estuary environments is maybe the warm water and kind of the different things going on maybe helps with that process of shedding that layer of skin. But yes, no, they do absolutely.
Okay. Another question I have here in the chat. So you listen to how human sounds impact the soundscape. So has the research noticed any changes, maybe them leaving areas that they might like because of too much sound?
Yeah, I mean, I think that's a question we're definitely starting to look at a lot more closely. And that's the big concern is that, especially with the way the Arctic is changing, maybe we're seeing a lot more traffic than we used to in different areas where we didn't used to have that traffic. Um, the soundscape of a lot of the Arctic, it's loud, but it's not loud in certain ways, if that makes sense. Like there is ice, there's waves, there are things going on that the beluga have evolved with hearing. But things like a lot of boat noise, that's going to be very new in what was a relatively quiet place, historically. So it's a great question, and it's something that we're looking really closely at. There is some research that kind of has shown beluga don't tend to call as much if boats are in the area. There's been a lot of kind of concern that, oh, if we're not seeing belugas in certain areas, is it because of boat traffic or is it something else that's going on in the environment? Sometimes it's kind of hard to know because there is a lot going on in the environment.
Yeah.
But definitely something we're curious about and something we're really trying to get a lot of information about and looking closely.
All right. And I guess location would change as well, or be location dependent, because if we look somewhere like the East Coast, the St. Lawrence, where you have a ton of shipping compared to the Arctic,
Yeah.
and we know it's really impacting the northern right whales. So I imagine that the belugas definitely hear the sound, and in some cases maybe it's affecting them as well.
Absolutely.
All right, let's check in with Miss Paget's crew again and see if they have a couple more questions for us.
Hi, my name is
Hello.
Abby, and I want to know, do the baby belugas have a higher frequency than the grown-ups?
Ooh, that's a wonderful question. And I don't know, to be honest. I don't know how age affects frequency. My guess would be probably just because even looking at us as humans, the kind of the pitch of our voices tends to change as we grow and as we mature. But I don't know offhand. That's a really wonderful question.
We
All
have one
right.
more.
Yeah, go for it.
My name is Jordan, and
Scoot over this one.
okay. My name is Jordan, and I have a question. Do the beluga baby whales do they use echolocation?
Do the babies use echolocation?
Do they?
Probably not, just because, especially when they're really, really young, they're depending on mom. They're nursing from mom. They're really mom is kind of their main source of getting food, so they don't necessarily have to hunt for themselves. Their mom probably uses echolocation around them because mom is still needing to feed and to find fish and whatnot. But the babies themselves, probably not until they start getting a little bit older, start becoming those subadults and start hunting for themselves. I think that calves typically are nursing from mom until they're maybe 2, 3 years of age. So that'll probably be when we start seeing babies trying to start hunting for their own sources of food, and mom will kind of show them, and they'll kind of pick up from the group around them how to do that for themselves.
All right. Great questions. Very
Do you have
cool.
time for one more?
Why not? Absolutely.
Okay, go ahead, Richard.
How old do they get?
Ooh, that's a wonderful question. So we think probably in the range of 30 to 60 years, depending, but I think it's still a little bit of a question. So we do know that belugas live for a longer period of time, and there's a lot of different things we can do to kind of see how long certain individuals live and try and kind of figure that out. One of the ways that we do that is if you guys have heard of tree rings. So beluga, there's layers of in their teeth that get laid down, and we can kind of look at those layers and try and figure out how old the beluga based is on the layers in their teeth. We can try and identify specific individuals, see if we find them again year to year, kind of try and figure that out this way. But we think 30 to 60 years, it's still a little bit of a question though, I think.
All right. Awesome. Another great question. I think what that shows us is there's still some pretty cool opportunities and research to be done. We're just scratching the surface of what we know about our ocean and what lives in it, because we only see a lot of these things for short periods of time. And we need to figure out innovative ways with technology to sneak looks into their lives more than we've been able to so far. Very cool.
Absolutely.
All right. Thanks, Mrs. Paget's crew. Great questions. Hope you guys have a great rest of the day. You guys were awesome. Okay, last question from the chat, and it really applies to what I just said, is with the Arctic changing, do you think there'll be more opportunities or careers in research in that area?
Ooh, absolutely. No, we always need more scientists. We always want to see more biologists, young biologists, learning more about the world around us. And especially, as you kind of mentioned, we know that the Arctic is changing. We know there are still so many questions and things that we can learn about these species, about the marine environment. And so, yes, absolutely, there's always room for more curious folks, for more passionate people that want to learn more about this incredible world around us, both in the Arctic and elsewhere too. There are a lot of amazing species and ecosystems that we still have so many questions about, and even a lot of what we've talked about today. I can tell you a lot of what we've learned so far and a lot of what we think is going on, but we're always collecting more information and questioning what we knew before and trying to learn more and better understand the world around us.
All right, awesome. Well, I do want to alert classrooms that we do have a Department of Fisheries and Ocean doubleheader coming up on the 31st. So at 9 o'clock Eastern, we'll hang out with Robin, and she's going to talk about ocean hitchhikers. So how invasive species hitch a ride on boats, in the tanks of cargo ships, and they cross oceans and end up in places they're not supposed to be, and what happens. And then we'll have Anya Dunham joining us, and she's going to talk about glass sponges and glass sponge reefs in particular. So we know about coral reefs, but glass sponge reefs are really, really cool. And the name kind of gives it away. They're inside of these sponges, they produce glass, which is pretty wild. And they produce these big reef ecosystems out on the west coast of Canada and probably stretching down into the US as well. So we're going to learn about those at noon on the 31st. A huge shout out to our classrooms joining us today. Thank you for those great questions. Thank you for playing Kahoot with us as well. It's always fun to see how you're doing and test your new knowledge. And then Ashleigh, it was so great to have you with us today and taking us into those soundscapes up in the north.
Oh, my pleasure. Thank you for having me. And thank you guys again for all those really great questions. It was really awesome to chat with you all today.
All right. Well, we're going to sign off for today. Hopefully we'll see you in upcoming events. But for now, we'll say goodbye and have a great rest of the week, everyone. Thanks.
Thank you.